Okay, so here we go. All right, and since we cannot have the correction back for the load summation because of the unforeseen incident, so let me try to go ahead and talk about the load summation on the beams instead. This should not be too difficult for you. So it will be pretty similar to what we have done before, especially in structural analysis number 1. Okay, that should be fine. Okay, so we shall begin with the roof plan first. You can see that you guys have been given the floor plan already, so that is convenient in a way. Generally in the real world, when you go out, you don't have you're not going to have a plan like this available to you, but maybe from time to time you'll be given the plan if they think you are junior, because to me, if you ask me, this is one of the most important part of the design and one of the most fun part, because you get to draw a lot of lines and sometimes you get to put the colors in your drawings as well. But after you're done with the planning, it's all calculation. Okay, so let's start by looking at the roof. Let's say we have the floor plan ready. So that means you see you will have your SB1 at every 2.5 meters. So apparently you will put the load on SB1, and it's pretty clear that the tributary width of SB1 is, of course, 2.5 meters. So this time you will put whatever the load that you have assigned on your system from the first phase onto this, plus let's say plus the weight of the slab. What comes before is, of course, what you can call the superimposed load, right? Superimposed load, any load that your slab has to carry plus the weight of the slab. So it becomes the weight of the beam, the weight that will be put on the beam. Okay, and because I write this before, so it's pretty difficult to perhaps read. So let me try again. Okay, superimposed. Oops, that you've done before, plus the weight of the slab. And in terms of superimposed, you may say you have superimposed date load and then superimposed live load. Live load is just live load. And when you have superimposed date load, when you categorize your date load, it becomes the date load in this category plus the weight of the slab. Now you may wonder about the weight of the beam. You may assume the weight of the beam beforehand, and then, or you can do later, because in steel structure, the weight of the beam is not a very significant part in design because it's not that much. Okay. And by using the tributary width equal to 2.5 meters, now you can have your load acting on your SB1. Okay, and if you are a very thorough person, you may say that, hey, this SB1 has the tributary width like 50% less than a typical SB1. Yes, you're right. And this one as well, because it supports only floor from one side. And the thing is that from time to time, it's just the two of them, this beam and that beam. So you may say, I'm going to use the same size. So it is, yes, a little bit uneconomical, but it should not hurt much because they're just two beams, just two of them that carries a little bit less. If there are a lot more like this, you may reconsider that. Okay, but since they're just the two of them, in this case, you may proceed by using the same size. Okay, and now where do all the SB1s go? They go to SB2. You know, the one at the grid line will go right into the column, so you don't have problem with that. But the one here, SB1, will be supported by SB2. Okay, so SB2, you can just, you know, do the load summation by having this and, you know, a point load coming from the SB1 acting on it, and plus the weight of the beam. Okay, and again, this time it will be a little bit more challenging. Please keep in mind that SB2 here shall be analyzed as a simple beam first, even though it may be part of the frame that you have to do it later with Ajahn Sutat, but this case, let's do it as a simple beam. Okay, and one more thing here. You see SB2 here, because I'm going to plan to analyze it as a simple beam here, so SB2 should be treated as a cantilever beam. Okay, and chances are you're going to need to check whether or not the moment from the first case here and the second case here, which one is greater. And if you plan to use the same size of the beam, you may just, you know, pick the worst case scenario from one of these two and then make sure that your beam will survive. Okay. This is the load summation that you need to do. You may not have to perform the analysis right away. Just make sure that you have the right load acting on the beam. Okay, so you have to sum a load on beam SB1 and then beam SB2. And that's it for the roof. And you may, keep in mind that SB2 has two cases that you may want to perform a little structure analysis just to see it for yourself, which one will govern. Because let's say if case number 2, which is cantilever, governs the whole design, that's not a good idea. Because you have a lot of, you know, SB2, the typical SB2 inside, you know. So to choose the size based on this particular one is not very efficient. So you need to do the load summation first and perhaps make decision later. I'm not sure if Ajahn Sutat would want me to ask you guys to do this, because there's an argument that not in terms of the true engineering aspect of things, but in terms of your practice. Because let's say if you design this as part of the frame, you will miss the opportunity to try to design the beam with, say, without the lateral support, because you can see that SB1 will be laterally efficiently braced by the floor system, but SB2, the floor will not help brace SB2. SB1 will be the beam that braces SB2. We'll talk about that later on. Okay, is there any question? All quiet. So let's move to the second floor. Okay, the second floor is very much just like the roof, except that we have a slightly different plan, and we have two zones of live load. Okay, so generally you would pick one beam. You would try to sum the load on this one. See, so this becomes the tributary width for your SB3. Okay, and since we have like 5 meters and we have 4 bays, so the tributary width is apparently 1 1/4, right? So you have two load sets for yourself. The one depends on what kind of room that you think you're going to build here. It's going to be supported by SB3. And then on this area, it's an area where live load is equal to 500. The tributary width is the same. Okay, so that's another beam. So we have two now. And you may say, you may have a problem with this one, but that's part of the frame. So I'm not sure about this, but you can say, you know, forget about the beams on the frame. First, it would not be much different from the ones that we do, but perhaps you need to run the frame analysis to get the member for that one. Okay, and if you can do the load summation for this and then for that, for these two beams, you should be fine when you do the load summation for the one in the frame. Okay, so that's two taken care of. Now let's time to move on. You have the one here, and it will be pretty much the same as on top. So I'll come back to this, but be careful that in the cantilever region you have two of them. Okay, so now let's move on to next one. I don't like this nomenclature very much, but it's okay, you know. Next is this beam. Let me change the color a little bit. It says right here that it is SB3 as well, but before you can go ahead and say that you're gonna use the same size for this red beam and then this beam, you need to make sure that it's okay to do so. And when you do the load summation for SB3, that is a secondary beam here, you need to do the load summation for SB3 here as well. You may use a different name, okay? You may use different name. Okay, but it is possible that after you check and you find out that the analysis shows you that the moment of these two beams are pretty similar. If that's the case, it is okay to use the same number. But the thing is that before you start assigning the name of the beams to each and every one of them, you just need to see the moment envelope that actually they carry pretty much the same moment. All right, or something like that. And don't forget that before we design it, we need to also take into the account the displacement or deflection of the beam. Okay, so let's do the load summation for this one. You may call it SB3. For that one, you may call it SB4. And this one, I would suggest you call it differently. But since it is indicated here in the drawings as SB3, you may want to say it's SB3X, SB3A, whatever. Okay, and perform the load summation on it first. And if you want, you can also try to do the structural analysis. Okay, and another one with this one. They use a different name here, SB4, probably because it will be different in size as well, because the loading from the two areas are different. And I don't have to do this for you, but you should know that the free body diagram of these red beams, it will be like this, right? 3-point loads, and you can analyze like that. And don't forget that you on this line, you guys also have the wall. So don't forget the wall. Okay, and then SB4 here, it's going to be pretty similar to the one on the roof, except this time you're going to have 2-point loads and the wall. Okay, and One thing that may confuse you a little bit, but I'm not asking you to do it yet, is the beams in the frame here, because if you sum the load on these secondary beams, you don't have any problem with the opening, okay, and you don't have any problem with this beam either. But you may want to go ahead and try to do the load summation on this one. Let's change the color once more. This one. What may be slightly confusing for you is that when I ask you to do the load summation on the columns, I'm asking you to use this as the tributary width of the column, because that's the width that the column, what that this column will carry, right? But when you perform this beam, the tributary width of this beam becomes just, you know, this width, because you're now looking at the beam, and this beam will also carry the weight, the load from the roof column as well. So this one will have to be super strong, okay, because it has to take the load from the roof, and before going into the column, it has to take the load from SB4 here as well. See, 2-point loads. Okay, so if you want to see what's going on, you can also try the green one, but let's make sure that you have SB1, a typical secondary beam on the roof with the tributary width of 2.5 meters, SB2, which is the main beam that supports the SB1, and then SB3 here, typical secondary beam that supports the floor with the live load that you choose. SB4 on the left side, the secondary beam that supports the area with the live load equal to 500 kilogram per square meter. And then the primary beam on the side, you know, again, they call it SB4 here. This is also 4, that is 4. So you may want to call this 4x, okay? And I need at least 6 of them, 2 from the roof, and then, you know, 3, 4 secondary beams on the second floor, and then 5, 6 the primary beams that support those secondary beams. I need 6 of them at least. And if you want to try the green one, please, you are welcome. Okay. So that's it. The beams for this project will be only this. Oh, and one more thing that I should add is that the SB3, the typical SB3 and SB4 here, all these beams, you know, this every beam here, they will be again braced by the floor. So this can be considered the beam with no unbraced length equal to 0. And for the primary beam, the unbraced length for this SB3X and SB4X will be equal to the spacing of the secondary beams. Okay, so that's it. Because we don't have that many beams on our structure, please make the right load summation, and I suppose you should be able to submit this next Tuesday. Okay, so I'm just gonna summarize this again and put it in the design phase number 2. All right, and let's hope that we can get the checked loading condition for columns back, so that we can talk about the design of the columns and the truss next time, and then the beams afterward. Okay, that's it for today. Is there any question? Hello? So if you're not going to ask anything now, I'm going to stop the share and stop the video so that I may get more questions, okay? Okay, it seems quiet. Oh,